Hello, in this episode, I will go over the questions in exercise 12D. When dealing with trig equations, keep this at the back of your head. The CAS diagram tells you in which the trig ratio will be positive. So I will go ahead and write down what the second answer can be, given the reference angle itself. And in the different color, I will write that in the radian conversion. So let me just move this a little bit. So once you have the reference angle, you can just look at the CAS diagram and see which other possible solutions the corresponding trig ratios can take place. So here we go 1a. We can find out what the reference angle is by doing inverse cosine of this number on the right, which is, so making sure that you are in degrees mode, otherwise you won't have the correct answer. Now your final answer wants one decimal place, so it's probably best for you to keep a few more decimal places. So here I will just keep 2, maybe 3 will be even safer, but I'll just keep it in 2 here. So that means the answers, because this is positive, right? This is positive. That means this is a particular answer. So this is a reference angle, I would say. So the possible angles will be the reference angle itself, because all three trig ratios are positive in the first quadrant. And the other angle will be, for cosine, is 360 minus. So therefore, that. So let me just rewrite this. So instead of actually writing it down, why don't I just write down what the answer has to be? So it will be 53.1, and then we do 360 minus. So 360 minus will give us 306.9, correct to one decimal place. So we're just going to keep going on with the other questions. So first we find what the reference angle is. So I get 8.63. So for sine, I want this to be in the first and the second quadrants. So I can go ahead and write this, correct to one decimal place. And I want to do 180 minus this, which gives us 171.4. Okay, so you should see the pattern over here. So we first undo the ratio and find out what the reference angle is. And then looking at the CAS diagram, we write down what those two quadrants it can fall under. So this would be in quadrant 1 and quadrant 3. So therefore I can add 180 to give us this other angle. For D, now this time this is a negative here. So what you can do for one option is just to take away the negative first in order to find out what the reference angle is. So this will be 37.23. And for tangent to be negative, we want this to be in the second and the fourth quadrants. So I will go ahead and do 180 minus the answer. And I'll do 180 plus that answer. So maybe I can go ahead and write down what those quadrants are supposed to be in. There's in 1 and 4, 1 and 2, 1 and 3. So that you know what I'm actually doing to get those corresponding angles. And lastly, for E, we first of all has this as a reference angle. 64.53. Then we note that for cosine to be negative, it will be in the second and the third quadrants. So I go ahead and do 180 plus and 180 minus. And there you go. Now I mentioned there's another way. So for this video, I will actually not go over it. Let's just stick with the cast diagram. Now question 2 is exactly the same, except this time we want everything in radians. So first of all, make sure that you are in radian mode. Otherwise, all your answers will be wrong. So we do the same thing. We find out what the reference angle is, first of all. Punching this in, we get now here, it doesn't say how many decimal place or significant figures, right? So unless otherwise specified, you should always keep 3 for your final answer. So in my case here, I will keep 4 sig figs for my angles that are not part of the final answer. So here, sine is positive in quadrants 1 and 2. So I will do quadrant 1's answer, and then I will do pi minus to get the second quadrant answer. Okay, so continuing on. So forget about the negative sign for now. Let's just find out what the reference angle is. So here, tangent is going to be negative in quadrants 2 and 4. Again, if you cannot visualize it, then draw out the diagram. So generating those two angles in quadrants 2 and 3, we get pi minus this should be 9 and pi plus sorry, this should be 2 pi minus because I want quadrant 4. So 2 pi minus that should be this instead. For C, we have this to be the reference angle. Now, when is cosine negative? Well, cosine is negative at quadrants 2 and 3. So therefore, I will do pi plus the reference angle and pi minus. Oh, sorry, I did it the other way around, but they're still equal. So I just switched the quadrant 2 and 3 answers around. Doesn't matter. The order doesn't have to be in order. Well, yeah. So for D, find out what the reference angle is. Oh, I should keep one more sig fig, which is 2, 0. And cosine is positive at 1 and 4. So I'll just copy the reference angle as one possible choice, but rounding it to 3 sig fig. And then I do 2 pi minus to get the other angle. And finally for E, find the reference angle for sine. Which is this. And it's negative at quadrants 3 and 4. So then I would do pi plus and 2 pi minus. And apparently this is different than the answer key. So let me just check again. I don't see anything wrong. Unless question meant to be cosine instead of sine. Nope, no idea. Oh, sorry. This here, 2 pi minus, I think I used the wrong angle from before. There you go. So I was just using the wrong line for when I do 2 pi minus. I think I minus the line before that. All right. Moving on. So we have this equation we want to solve. So what we want to do is to set it equal to 0. And then this should remind you of a quadratic form. So we can factor out this. Now, if you have problem with this step here, then I suggest you do some more factorization practice. You can also use quadratic formula and plug in the coefficients, but it takes a bit of work. So I suggest knowing how to just factorize these sort of simple trinomials. Then we break each brackets and equate them to 0. And then we solve them individually. Okay. For this question, actually, I don't really need a calculator because sine theta is 1/2 when exactly this is pi by 6. We're in radians, so this is equivalent to 30 degrees. But this is just a reference angle, right? So therefore, the other angle is actually pi minus. So when I do pi minus that, I get the second. Let me write it like this. So the reference angle is pi by 6, and then we want both the first and second quadrant answer. So therefore, the angles would be the first quadrant answer, which is the reference angle, and then we do pi minus. Pi minus will be 5 pi by 6 as a final answer. Now onto the right-hand side. When we isolate this part here, notice that sine theta can never go below -1. So this is the domain for sine. Sine has to be between, so I should set sine theta has to be between -1 to +1. So when you actually look at the sine wave, this only goes up. Okay, it only goes up to 1 and it goes down to -1. So it cannot be like at -3 here. So if this is like y equals -3, there will be no intersection. So this is impossible. So we have no solutions here. So combining those, the final answer would just be pi by 6 and 5 pi by 6. Okay, so all parts of question 4 is asking you to do the same thing, but give your answers correct to 2 decimal places. So here in the first one, we can start off by moving 3 sine x over. Then whenever I see sine and cosine, one on each side, I know I can convert them to tangent. So I will go ahead and divide both sides by cosine x. So you either divide by sine x or cosine x, but because tangent has cosine on the bottom, you probably want to divide cosine. So this simplifies to 4 equals 3 tan x. And then if I divide 3 to both sides, I have now isolated x. So I can use the reference angle. So the reference angle of x will just be inverse tan of this, which give me 0.927. We want 2 decimal places, so I'll just keep 3 in my working. Now, I want this to be positive for tangent, so this will be in quadrant 1 and 3. So therefore, my x's will be the reference angle, and then this pi plus. And rounding it gives me 4.07. Okay, B is very similar. So I can move cosine to the other side, divide both sides by cosine x, and then isolate tangent. So the reference angle is going to be inverse tan of 1/2, which is 0.464 correct to 3 sig fic. Now we want this to be negative, so that means the angles that I want to generate will be in quadrants 2 and 4. So therefore x will be pi minus and pi plus. No, 2 pi minus. So what I do is I will go to the GDC and type in like 2 pi minus, and then I will just hit up until I get the answer line for the reference angle. So I don't have to type in the whole string of digits. And that's it. So here is C. So immediately, this is already in quadratic form, so we can factor out the trinomial as follows. We can have a -2 and a +1. So let's break each case down to their individual roots. So first of all, we have tan x equals to -1, or let's do the left-hand side first. So -1, technically, you don't need a calculator because this is at 45 degrees. In terms of radians, this will be pi by 4. So I want this to be, let's move this a little bit so I can have some writing space. So this is -1. I want tangent to be negative. That will give us quadrants 2 and 4 as our answers. So then we have pi minus pi by 4 is 3 pi by 4. And then 2 pi minus pi by 4 will be 7 pi by 4. Moving on to the right side, we isolate tangent x to become 2. Therefore, this reference angle will be tan inverse of 2, which is 1.107. I'll just keep 3 decimal places here. And then, this time it's positive. So I want the answers in quadrant 1 and 3. So my final answer will be 1.11, and then pi plus that. Oh, because the question asked for 2 significant figures, no, 2 decimal places, I have to write this in decimal places. So I still have to use my calculator for this. So this is 2.36 and 5.50. So maybe if you want to be really specific, then just write everything down on the same line. Otherwise, if it's obvious, then the examiner will know anyway. All right. Now, this looks like quadratic form, but it's not quite so because they don't have the same ratio. One is sine, the other is cosine. So what we do here is we employ one of our trig identities to change cosine square x to sine square x. So then let's do a bit of simplification and collecting like terms. Now I don't like the negative in the front, so what I'm going to do is multiply everything by a -1. So in effect, I'm switching all the positive and negatives. And then now I can factor this. Again, we're going to set each of these equal to 0. So therefore, we have sine x equals to -1/2. And therefore, the reference angle. So sine is 1/2 when it's pi by 6. So we know that's the reference angle. And we want the answer to be negative for sine. That gives us quadrant 3s and 4s. So therefore, again, I will do pi plus, which is 7 pi by 6. And then 2 pi minus that, which is 11 pi by 6. And I will just crunch it into the calculator. 3.67. And 5.76. Now over on the right hand side, now because I know sine x equals to 1 when it's exactly, so if you draw the unit circle, these are some exception case. I know this will be at 1, right? We want a y coordinate 1 when this is at pi by 2. So therefore, this is just pi by 2. And I will just put that in the calculator. So for every cycle, sine will only reach a height of 1 once. So therefore, there isn't a second angle. So combine them together, I have these to be my final answers. Okay, question 5 again. This time we have a different domain, so we can go beyond our normal 0 to 2 pi domain. So what do? Well, everything that we have done so far, we start off actually at the same place. Find the reference angle. And then determine when this is going to be positive for cosine. It will be quadrants 1 and 4. So therefore, this will be 1.266. Now, I'm not done yet because this is not my final answer. So I'm just writing 2 particular answers because I can go beyond 0 and 2 pi for the angle. So this will be 2 pi minus which gives me 5.017. Now let me just convert this to decimals. So from negative pi to 2 pi, 3 pi. So I have these decimal approximations. So that means my angles has to be between that. So I'm going to take these string of numbers, these 2 angles, and I'm going to keep adding 2 pi until it goes outside of that range. So if I do this plus 2 pi and this plus 2 pi, I will have 7.549. And for the second one, it will be 11.30. So you notice that this goes above 3 pi. So therefore, we will keep the other 3 angles. So now we can round this to 3 sig fig. Now, what happened to the negative one, right? I didn't actually talk about things that are beyond that. So what you could also do is, instead of adding, we can also subtract. So what happens is, I could also go back up here. Let me make some space here. I could also take these lines and didn't know I can do that. But that's not what I want. Okay, I can also take these particular answers and do minus 2 pi, and then I will actually get some other answers. So the first one is negative 5.017, and for this one here, I will have negative 0.1266. So notice that this also falls outside of the domain. However, this one we keep. Okay, we keep this one. So then now we can write everything down as our answers. So the process here is if it's beyond 0 and 2 pi, you actually have to go back and forth cycles of 2 pi. And you just keep doing that until you have all your answers. I'm going to write this in another way in the next example here. Okay, so tangent. So the reference angle is this here. Now, I haven't mentioned this before, but tangent is actually special because you can actually collect the two angles into actually just having a one particular angle and then just adding a period of pi on top of the solutions. So what I mean is this is one particular solution because first of all, this is positive. So we know that this is in quadrant 1. And this will be positive for tangent. So we can go ahead and write down this solution. And then we can just keep adding multiples or minusing multiples of pi. So we can do this. We can do this. So we can just keep adding multiples of pi, and that will give us all the possible solutions. So let me just change this to a decimal approximation so that I know when to stop. So I go ahead and write this, simplify this. So on the calculator, you have your answer line, right? So this is rather nice because all you got to do is to take each line and then just keep adding pi to it. And I lost my answer. So the first one stays the same. And then you just press plus pi on your calculator. And then that reads off the next angle. And then you do plus pi again. And then this gives you the next answer. And then you do plus pi again. And we got the next one. Oh, this is not 3 sig. Now it is. And I do plus pi again, but this falls outside the domain. So I'm just going to cross it out and leave this as that. If you write it in pen, maybe you need to write another line. Okay, so these are our 4 solutions. Okay, this only works for pi. This only works for tangent because tangent is special. Okay, next one. So what we do first is divide both sides by cosine. And we get tangent on the left. So let's go ahead and find the reference angle. And this will be 1.107. So again, it's tangent, right? So what we can now do is actually just find one of the solutions for tangent. So it could either be in quadrant 2 or in quadrant 4. Okay, and I just need one because once I have one of the answer, I can just add pi to get to the other answer, or similarly, I can minus a pi to get to the other answer within 360. But you will see that actually you could actually add pi to get from, you could actually do add pi and minus pi to get to these quadrant answers as well. It's just that they are going to be in different directions. So one is going to be like anti-clockwise fashion. The other one will be in terms of clockwise fashion, but they still point you to the right point on the unit circle. So that's exactly what I'm going to do. So I'm just going to take my answer in quadrant 2. So this will be pi minus. So this is the answer in quadrant 2. Okay, so this is answer in quadrant 2. And then I'm just going to keep adding and subtracting multiples of pi until I have all my answers. So notice that this is from negative 3.14 to positive 1.34. And if I actually attempt to add pi, this is going to go beyond. This is going to be 5 point something. So I know I can't generate beyond that. So what I can try is to do 2.03 and minus pi. So go back one cycle and then see if this is going to fall within the angle domain. And in this case, it does. Now, if I try to do minus 3.14, I know it's going to be way less than negative 3. So if I do this again, I know this won't work, so I'll just stop there. So these are going to be my two solutions. Okay, so again, with tangent. Tangent is nice. So we can start off by factoring the trinomial. Well, let me just do one extra step. It's by setting this equal to 0, so we can move the 3 to the left-hand side. So now we can factor out the trinomial. This is plus 3 minus 1. So then we break each one of these into zeros. And then we can solve for them. So this will be tan theta equals 1/2. Again, I have my reference angle to be this value. So tangent, you can just take, because it's positive, so that means this is one possible solution. Hopefully that's in the domain that we give in. And then we can just keep adding pi's or subtracting pi's to get everything. Oh, so in this case, it actually falls outside. So, well, let's just minus a few of these here. So if I minus a pi, and then minus 2 pi. So I know I cannot add pi since this is already beyond 0, right? So I have to map it backwards. So if I subtract a pi from the answer, I have 2.68. And if I minus it one more time, I get minus 5.82. So that's still okay because this number here should be negative 6.28-ish. So then if I do it one more time, right, if I try to go backwards 3 pi worth, I know it's going to go below. Okay, so this is way too small. So your answer would just be these two here. Oh, actually, sorry, I forgot the right-hand side. So those two answers are for the case on the left. So let me just erase this first. And let's take care of this part here. We have x equals arctan of 3. By the way, let me show you one more way here. Instead of actually dealing with positive and negative, tangent is also nice because you could also just do it like this. You can actually stick the negative in there, and the calculator will still give you an answer. And that answer will always be a possible angle, even though it is in the negative sense. Okay. So you can actually test it out by doing inverse tangent of positive 3 and then go through the cast diagram and all that. So you can confirm that. So what I do is I will take this answer now. Technically, this is not this is a particular answer. I mean, I can still call it reference angle because it still works. So what I do is I will copy this and then I will just keep adding or subtracting multiples of pi. So I can add pi, I can add 2 pi, etc. But I can also go minus pi, minus 2 pi, and so forth. And then you'll see that from within these answers, the first one works. I can't add a pi because that will be bigger than 0. So therefore, these two won't work, I know. I could also do... Did I copy the answer down wrong? Where did I get 1.125 from? I have no idea. This is 1.249. So if I try to add multiples of pi's or subtract them, then these won't work. This won't work. Yeah, I think the last one won't work. Oops. So let me just round this to 3 sig figures. Well, so it will work up till this number here. Then I can combine to two cases and just write them down in one straight line. Lots of negatives. Only negatives, actually. Okay, and for our final question. So this is from 0 to 360. Remember to change it back to degrees. And this is a straightforward question. You don't even have to go plus and minus 2 pi because it will be already giving you the solutions within the first cycle. So let's divide both sides by cosine x. So then I can isolate that and give an expression for tan x. So therefore x is just inverse tangent of 3/5, which is 30.96 degrees. I'll just keep 2 decimal places right now. We want this to be in quadrant 1 and 3. So you notice that in order to go from quadrant 1 and 3, we actually add 180. That's what we were doing with the question before. We just keep adding like pi, which is actually 180 rotation. Or we can also, likewise, minus 180 to go backwards. So therefore, the angle will be the given one. Let me round this to the nearest degree. And 180 plus, which is 211. And there you have it. Hope you guys learned something.